I want to start by looking at scan data, which we can bring into Alias either as a polygonal mesh, as I have here, or as section lines. And if I take a look at the File Open options, you can see that Alias will open most engineering formats, so you should be able to get your mesh into the scene. This one here is half of a scanned hood of a car, and I'll start by looking at some of the display options. If you went through the fundamentals tutorials, you'll have seen the transparency sliders over here on the control panel. And the mesh one is really essential for lightening up the mesh so that you can see the structure of the scan and the shape. If you have a very large mesh that is data heavy and it's slowing down the interaction, then down here on the quality section you can reduce the mesh density, which means it only draws a portion of the mesh triangles. And this will improve the speed of tumbling and interaction on the screen. This flat shade meshes option applies when I'm using the diagnostic shading on a mesh, because by default it will smooth out the polygons. So we can see here the typical nature of scan data, which is that it gives a very good reading of the overall shape that's been scanned. But down at the detail level there's noise which will cause these small deviations. And it's these we need to design out of the NURBS model that we build to replace it. So if I don't want to see that smoothed version, then I can pick the mesh and say flat shade. And then the triangles are shown accurately instead of smoothed. Now I want to take a look at the mesh tools over here on the mesh palette. And I'll switch to the polygon model of the car. Now this isn't actually a scan, it's been created in 3D Studio Max. But it'll work as an example to show us some of the mesh tools. And I personally tend to use the right-hand mouse button to access the text version of the tools, as I don't use them often and I find it easier to locate the tool names rather than the icons. And you can use the Alias help to take a look at each of these tools, but I'm just going to show you a couple, starting with the mesh subset. When we bring the data into Alias, we may need to reduce it down or separate it into different segments that we can put onto layers to isolate parts of the design. So on this one, for example, I don't need both halves. So I can use Mesh Subset and then pick the mesh and just sketch out an area that encloses the part of the mesh I want to delete. And you notice here that it hasn't picked all of this mesh, so I may need to do it a few times. And it depends on the structure of the data that you bring in. And this one is grouped from the 3ds Max file. It may also depend on which view you're working in as well. But that's good enough for now, and I've got it reduced to half a model. And later on I'm going to use only the side glass area to show you the barrel tools for creating side windows, so we may want to subset that. So I'll just trace around the window area, and I'll just be a bit more careful around the details. And then say select, but this time I want to say subset instead of delete. And this means that I can take these parts, for example, and make them invisible, or put them on a layer, and just be looking at the side glass mesh and working on that. Another tool that can be useful is the Mesh Extract Theoretical Intersection. If I click on that and then pick the mesh model, then it shades it up with a curvature shader. And we're not interested in particular values of curvature here. We're interested in picking up the feature lines. And you can see that they're clearly visible in the red and blue areas of maximum curvature. So with the extract tool selected, I can click along this edge here to extract the feature. And I can adjust the size of the area to be sampled, and then say update. And then if I pick nothing, you can see it's created two lines for me. One is the line of the feature on the surface, which is on what is probably a fillet surface. And one is the theoretical intersection, which is where these two surfaces would meet before the fillet is applied. Now this is quite a rough polygon model, so we're not getting a particularly good result here. But it can help to just get some more reference data from the mesh. Now another approach is just to shade up the polygons using the curvature evaluation shader here on Diagnostic Shade, and then to use blend curves. Because a blend curve will attach to a mesh without using snapping, and you can trace around any feature lines that you want to capture. Now this is not going to be the theoretical, It's on the surface feature line, but it's still a useful way to extract out some key reference data. So that's got you started with analysing a mesh, and in the next tutorial I'll look at working with section data.